Hello, welcome again. We are solving some questions of machine design. The topic is bolt, shaft, rolling and sliding contact bearing. Question number 5 is a shaft ported at ends in ball bearing carries a straight tooth spur gear at its mid span and is to transmit 7.5 kilowatt at 300 rpm. The pitch circle diameter of the gear is 150 mm. The distance between central line of the bearing and gear are 100 mm each. The shaft is made of steel and allowable shear stress is 45 MPa. If the pressure angle of the gear mounted is 20 degree, then diameter of the shaft is option A 32 mm, option B 30 mm, option C 39 mm and option D 43 mm. So this is the shaft and a gear is mounted on it. Its diameter is 150 mm, physical diameter is 150 mm. Then these are the two bearings and distance between the center line of the bearing and gear is 100 mm each. So this is a schematic diagram according to the statement given. Diameter, physical diameter 150 mm and distance between bearing is 100 mm each. Okay. So here the power transmitted given as 7500 watt or 7.5 kilowatt at 300 rpm. So diameter is 150 mm or 0.15 meters and length between bearing is 200 mm or 0.2 meters. Shear stress, allowable shear stress in the shaft is 45 MPa and pressure angle is 20 degrees. So from the power given and RPM we can find out torque transmitted. So by using 2 pi nt by 60 is equal to P. So T comes out as P into 60 by 2 pi n, or it is your 238.7 Newton meter. Okay. So the torque transmitted is your 238.7 Newton meter. So this the torque is transmitted by the force along this. This is your common tangent to the to both the gears in mesh, because power is being transmitted. So here there is one gear and it is the power being will be transmitted from the by matching with another gear. Suppose another gear is here, okay, and this is the common tangent to the common tangent of the two gears, okay, and the power is being transmitted by by the force along this line. And if we multiply this force along this line and with diameter or with radius of the gear, then it is your torque transmitted that we have calculated. Okay, so the torque transmitted is so torque transmitted we have calculated, that is 238.7 Newton meter, and that will be equal to force along the common tangent multiplied by pitch circle radius, or Ft into d by 2 will be equal to T. So now Ft will be force transmitted along this common tangent. Okay. So so Ft comes out as 3182.7 because diameter is just 0.15. Okay. Now as two gears are in mesh, so some normal force will also be acting on these two gears, or we can say it is radial force. Okay, and this radial force keeps them in mesh, and this is the line of action, or along with the resultant of force required for meshing and force transmitted uh, along the common tangent. Okay, the at with the resultant of these two acting. Suppose Fr is this, Fr means radial force is this and force transmitted is this. So resultant of two will be in this direction. Now we have Ft and we have this pressure angle. Okay. From this Ft, from Ft and from the pressure angle, we can find out resultant force or the force along this line. Okay. So this angle is pressure angle and force along this line we can calculate. So this is ft, and angle between them is your 20 degree, and this is a line of resultant force. So the resultant force will be ft divided by cos alpha. So resultant force will be your resultant force on the force acting on the gear tooth, or force acting along the line of action of the gear, is ft by cos alpha. So that will be your 3387. So this is your w. Okay, so that w will act on this gear and will cause bending of the gear, or bending of the shaft. So uh, so from this, as this load is acting along the line of action of the gear, so the it will cause a bending of the shaft. It will try to cause a bending of shaft. So bending moment is, as it can be assumed as a simply supported shaft with point load at midpoint. So the bending moment will be, for that bending moment will be WL by 4, or we can say, if W is the force acting on this gear, then R by W by 2 and W by 2 force will be the reactions, and W by 2 into L by 2 is your bending moment, or it will be WL by 4 will be the maximum bending moment at the midpoint, and that value is 169.4 Newton meter. Okay, so that is bending moment, and the equivalent torque is your this 238.7, and torque is your 238.7. Sorry, equivalent torque, not equivalent torque. The torque applied is your 238.7. Now we have bending moment. Okay, and we have torque also. As this bending moment may cause shear stress in the shaft, and this torque can cause bending in the shaft. So we have to consider the effect of both. So considering equivalent torque, so equivalent torque is your root m square plus c square. So value of bending moment is this 169.4, and value of torque is this 238.7. So equivalent torque comes out as 292.7 Newton meter. As only the shear stress is given, so we'll design the shaft according to equivalent torque. And from the torsion equation, we have T by J is equal to tau by R, or here T is your TE, or we can say because J is pi by 32 d4, so TE will be equal to pi by 16 into tau into d cube, or from this tau we have 45 ampere. So from this we can d we can have 32 mm. So answer is the 32 mm. So the using that TE by J and tau by R, and J is your pi by 32 d4 and R is d by 2. So from this we have torque is equal to pi by 16 tau dq. Okay, and from this we can have d as 32. Okay. So answer is option A.